Chapter 7, Lesson 1, Power Functions. A power function is a function in the form of f of x equals x to the nth power, where n is greater than 0. The graph of a power function looks like this. It's kind of like the half of a parabola, so that's an easy way to remember it. You also have to remember that the probability of repeated independent events states that if an event has the probability of p, and each occurrence of an event is independent of all other occurrences, and the probability of that event is p to the nth power if the events occur in a row. An example of that would be if Jim is going to take a 5-question multiple choice test that has 4 answers per question, what are the odds that he gets all of the questions correct? So the odds of him getting 1 question correct, because there's 4 answers, is a 1 out of 4 chance of getting that correct. For the first question. The second question is 1 of 4. Same for the third question, and the fourth question, and the fifth question. Be 1 over 4. Or 1 over 4 to the 5th, which, if you typed it, you do 1 over 4 to the 5th, which would equal 4 to the 5th would equal that, so it would be 1 over 1024. And those are his chances. The odds that you would get all of the questions on the test correct. Another example of that would be that Hank spins a spinner with 5 even sides, red, yellow, blue, green, and black, 3 times. And what are the odds he does not land on black at all? So if he has a 1 in 5 chance of landing on black, then he would have a 4 out of 5 chance of not landing on black for the first one, the second one, and the third one. So that would, you would do 4 to the 5th to the third, which would equal that, 5/12, and you do math fraction, that which would get you 64 over 125. Or an easier way to do it would just do 4 over 5, do 4 to the third, or 5 to the third, which would get you 125. So that pretty much sums up 7-1 power functions.
Right, this is Chapter 7, Lesson 4, which is all about compound interest. Compound interest is the addition of interest to the principal sum of a loan or deposit. There are 2 types of compound interest. There's annual compound interest and general compound interest. Annual compound interest is let P be the amount of money invested at an annual interest rate R compounded annually. Let A be the total amount after T years. Then A equal P times 1 plus R to the T power. General compound interest is let P be the amount invested at an annual interest rate R compounded n times per year. Let A be the amount after T years. Then A equal P times 1 plus R over n to the n times T power. Let's start with annual compound interest. The formula for this is A equals P times 1 plus R to the T power. This formula would mainly be used when interest is compounded annually. Let's say that Jeremy deposits $4,000 this year in a 5-year certificate of deposit. The investment is guaranteed to earn interest at a yearly rate of 5%. If no money is added or withdrawn, how much money will Jeremy have after 5 years? Let's set up the problem. Start with A equals 4,000 times 1 plus 0.05 to the 5th power. Now make the problem simplify. A equals 4,000 times 1.05 to the 5th power. Now put 4,000 times 1.05 to the 5th power into the calculator, like so, and press solve. The answer should be $5,105.13 because you have to round. The final answer will be Jeremy has $5,105.13 after 5 years. A good way to remember the formula is that the starting amount goes first, rate plus 1 goes second, and years of time is third, and always an exponent. Now let's do general compound interest. The formula for this is A equal P times 1 plus R over N to the NT power. This formula would mainly be used when interest is compounded more than once a year. Let's say $20,000 is placed into account that pays interest at a rate of 5%. How much money will be in the account after the first year if interest is compounded quarterly? Set up the problem like this. 20,000 times 1 plus 0.05 over 4 to the 4 times 1 power. Then solve it. Then you would plug in 20,000 times 1.0125 to the 4th power into the calculator to get the answer. The answer would round up to $21,018.91. The final answer is that $21,018.91 will be in the account after 1 year being compounded quarterly. The way to remember this formula is the starting amount goes first, rate over number of compounds goes second, and number of compounds times time is third. If you're getting the formulas mixed up, remember that annual has no end number, general does. Also, annual is yearly and general is more than once a year.